Hello again, everybody. Welcome back to a new screencast lecture. Today's topic is renewable energy resources. In a previous lecture, Introduction to Energy, we discussed what energy is and what it can do. This brings us to the question, where do we get the resources that make our energy? The source of energy is known as an energy resource. One of the big topics common in the news nowadays, and also on some standardized tests, is renewable energy versus non-renewable energy resources. Okay, let's talk about renewable energy resources. Let's get a definition. A renewable energy resource is one that can replenish itself within a reasonable amount of time. A reasonable amount of time is not a strict definition. We can use maybe a person's lifetime, maybe about 100 years or less. We consider that renewable resources. Renewable energy resources, we're going to go over things like what are some examples of renewable energy resources, and of those examples, what are some pros and cons for use of each of those resources. First, we need to understand the basics of how electricity is produced so that we as humans can use it to do things like run our refrigerators, heat our homes, turn lights on, run our computers, whatever we want. The basic idea is to spin a magnet inside of a coil of wire, or have a coil of wire going around a magnet. An electric generator will induce current. Here you see a coil of wire, right here. Here's the coil of wire, it's spinning inside of magnets, and that is making electrons move through the wire. It's inducing current. Here's another diagram. Here you see a coil of wire spinning. Here's the magnets, and it's making the light bulb turn on and off. Same kind of idea on a larger scale. And here's the opposite one where you have a magnet spinning around inside of coils of wire and inducing current, as you see here. Pretty much all electricity is produced by using a spinning turbine to power the generator. So the trick is how do we get the turbine to spin? That's going to depend on what energy resource we're going to be using. Let's start with hydropower. Hydropower is the biggest producer of renewable resources. How does it work? Hydropower uses the force of falling water to turn a turbine, which generates electricity. Ultimately, hydropower gets its energy originally from the water cycle. Water evaporates, goes up into the atmosphere, and then it falls as rain and collects in lakes and rivers. And in this case, we're going to have these lakes and rivers maybe uphill, like in a top of a mountain or high places like that. After collecting in lakes and rivers, water is going to flow downhill. And so it's getting its power now from gravity. Gravity is pulling the water down. You can see the power of falling water in this photograph. Here you see the water, basically it's a man-made waterfall, and water is pouring down through the dam. So the water up here is called a reservoir, and that's quite a bit higher than the water down here. So the water is going to fall a great distance and has a tremendous amount of energy and a tremendous amount of power. Here we can see this in motion. So here's the water in the reservoir. It's going to go through the intake, so a pipe here through the dam, and as it goes through, it's going to spin this turbine, kind of like a big water wheel, and that turbine is going to move the generator. The generator is going to make electricity, and that electricity can be used in people's homes. What are some positives about using hydropower? Hydropower is a really good choice because, first of all, the river is going to be flowing 24/7. There is going to be virtually no pollution from this. You're not burning anything. I mean, this is fantastic. Some negatives of hydropower. One of the negatives would be that a dam itself can cause ecological damage. So here is a river in 1987, they built a dam, and here's the reservoir, so it changes things in this area quite a bit. So you can see the difference between this area, and that could make homes for animals vanish. You can see the vegetation is quite a bit different, and downstream there could be changes as well. Fish spawning, that could be a real problem. So like, for example, let's say fish would normally swim up the stream to spawn and breed and make new fish. Now that there's a dam there, they can't get through to get up there. So That could be a problem in terms of the wildlife in the area. Here you can see a fish ladder. This is going to allow fish to swim around the dam to get to their spawning areas. So this is an idea to come up with to help with that problem. Here you can see this fish is going up the fish ladder to be able to go upstream and make new baby fish. Next, let's take a look at solar power. Solar power uses the radiant energy from the sun to produce electricity or to capture thermal energy. For example, solar power in its most basic, you go out and you sit in the sun and it helps keep you warm. That's using solar power. Now, when you were talking about generating electricity, solar power is an exception to what I was talking about before about how most electricity is made by spinning a turbine. Solar power does not do that. Solar power generates electricity without spinning a turbine. So how does it work? Keeping it relatively simple, you have a solar panel, and that solar panel allows photons or particles of light to knock electrons free from atoms, generating a flow of electricity. And most people have a little solar panel on their calculator, so these are things that are very, very common, and they're becoming less and less expensive. Here you see the sunlight affecting the photons and causing electrons to move, which is inducing electricity. What are some positives of solar power? First of all, once you pay for the system, which can be kind of expensive in the beginning, but after that, the electric power is virtually free, as the sun is there for everyone. One of the cool things about this also is if your house is still connected to the power grid, you can actually sell back unused electricity. So if you make more electricity than you use, you can sell it back to the power company and make some money. Here you see this in action. So the solar panels are generating electricity. The electricity is being used in their home, and the additional extra energy can be put back into the power grid. Pretty cool. And another good thing about solar energy, of course, is that there's plenty of sun. I mean, that sun's going to be lasting us for a long, long, long time. A lot longer than we'll be here. What are some negatives of using solar power? Well, the most obvious negative of solar power is that the sun is not always out, is it? Like, for example, during the nighttime, you don't have a whole lot of sunlight. So solar power is not always available. If you have a cloudy day, kind of like today, we have a cloudy day, you're not going to have as much electricity, or sometimes not even enough. And since the sun is not always going to be shining during the nighttime or clouds, if you need to use electricity, you're going to have to store it somehow. So during the day, you have to generate more electricity than you use and then store it in batteries. Now, one of the problems about batteries is they can be very expensive, and they also be kind of dangerous too. So you need to have proper ways to store the batteries. Okay, our next energy resource is wind power. Wind power uses the mechanical energy of the wind to generate electricity. Well, how does it work? Now, this is a pretty neat one because this is a direct spinning of the turbine. So the wind is going to be directly spinning the turbine. We don't need to make steam or anything like that, like most of the ways to make electricity. The wind is directly moving the turbine. The turbine is connected to the generator that spins the generator, magnets, wires, and that's going to be making electricity. So wind is spinning the turbine blades and powers the generator to induce current, as you see here. As the turbine spins, you get the generator to spin as well. So what are some pros of wind power? Well, wind is free, all right? The wind is out there. Nobody's going to charge you for wind. You don't have to do a whole lot to make a windy day. Wind does not cause air pollution. You're not burning anything. You're not sending any smoke up into the atmosphere. So it's a very, very clean energy. What could be some negatives about using wind power? The first most obvious is kind of like with solar power, that the wind is not always going to be there. You need to have a certain amount of wind to be able to move the turbine to get enough electricity. Another negative is that a wind farm can occupy a lot of space. Here you see a photo of a wind farm in Indiana, and there's just hundreds of these wind turbines, and they go on for miles. Here you see a close look at just how big these blades are. Wind power has some pretty unique and odd negatives. One of the negatives is that the spinning blades can kill birds. Another problem is that the wind turbines can cause noise pollution and shadow flicker. What noise pollution is kind of like when you're driving down the street and the car next to you has their stereo on too loud. You can actually feel that rumbling in the ground, through the ground. And some people who live near these wind turbines have reported that they can feel vibrations through the ground, and it's really quite annoying. The shadow flicker, the idea behind that is when the blades spin, they block the sun and they can cause a shadow to go over your home or wherever you are, and then the shadow goes away and then it comes back on again, and it's almost like a strobe light, so it can be quite annoying. So here you can see a clip of what this might be like if you're sitting in your home. This is somebody's home in Wisconsin, and they're near one of these wind turbines, and this is kind of one of the effects that they experience in their home. Our next renewable energy resource is geothermal. Geothermal, if you take a look at the name, you can probably kind of figure it out. Geo meaning earth and thermal meaning heat. So what geothermal is you're using heat from the earth for energy. How does it work? Well, high pressure steam from deep under the earth's surface shoots up and it will spin the turbine, and that turbine can move the generator and make electricity. So like instead of a windmill or a wind turbine where the wind pushes the turbine around, you have steam which is shooting through and spinning the turbine. That steam is coming from below the earth, comes up here, goes shooting through, spins the turbine, kind of like a water wheel or a windmill, and that's going to move the generator and produce electricity. It's really pretty neat, pretty clever. So why is geothermal a good choice for energy production? First of all, geothermal can provide constant, clean electricity virtually anywhere. So a really big advantage over wind power and solar power is the heat from the earth is going to be constant, year-round, always happening, doesn't really depend on anything. Certain areas of the earth are definitely better for geothermal choices than others. Here, for example, is Iceland. Iceland is a volcanic island, and it's very close to the heat sources underneath the earth. And here you see a really neat geothermal plant here in the background, and close to it is this natural hot spring. So you can see that these people are wearing very warm clothes. This person's wearing a parka and winter clothing. The rest of these people here are swimming and enjoying the hot springs. That's pretty neat. Another advantage of geothermal is it can be used on small scales. So even you in your home, you may have a geothermal heating system. The way this works is pretty cool. Down below the Earth's surface, the temperature stays the same year round. Doesn't matter if it's winter, doesn't matter if it's summer. So the idea behind this is if this is summer, what you're going to do is you're going to take warm air from in the house, and you're going to pump it down below the Earth's surface, and that's going to cool that air, and then it's going to come back up, and that can be used to cool your home. In the winter, underground, the temperature is going to be warmer than the temperature in your home, so you're going to pump the fluid down underneath. So here's the cold from the home getting pumped down underneath the earth, and then the earth is going to warm it up, and then that warmth is going to be able to come back up and be able to be used to keep your house warm. That's really, really clever and very, very efficient. The original system's pretty expensive, but after that you can heat and cool your home for much lower than you can with other forms of heating and ventilation. There's really not much negative about geothermal. Probably the one big negative is that even though it can be used anywhere, certain places are definitely better for it. We mentioned Iceland. Other places, it may be very, very expensive to dig down deep enough to be able to get the positive effects of geothermal energy. That's about it. Our next energy resource is biomass. A definition of biomass is the generation of electricity or heat from burning living material like plants. Some examples of biomass fuels could be wood, corn, grass, pretty much anything. So how does biomass work? Well, biomass is normally used for thermal energy, heating, and cooking. In this case, it's really pretty simple. I mean, here you see a wood burning stove. You put wood in it, you let it on fire, and it gives off heat. The heat energy may be also used to make steam, just like we did with geothermal, and that steam can be used to spin a turbine and generate electricity. So here we have biomass. Let's say this is corn. We're going to burn that. There's going to be water. That water is going to boil, make steam. That steam is going to shoot through the pipe, spin the turbine, like kind of again like a water wheel or a windmill, and then that's going to move the generator. The generator is going to induce electricity, and there you go. Biomass. Why is it good? What are some positives of using biomass? The big thing is biofuels are renewable. Like if you cut down a tree, plant a seed, it's going to grow back. This is interesting. This is cow manure. So where the energy comes from this, if you think about it, a cow is going to eat grass. The grass is flammable. The cow eats and digests the grass and poops it out. That manure is actually still going to be flammable because it's made out of plant materials. Here you see a woman cooking bread on a fire that is made with cow manure. Here's an article that I saw on Fox News that could cow manure be the future of green energy? I don't know. Hope not. Biomass, an advantage of biomass is that it can be really easy to use. I mean, you can't get much more simple than a oil lamp. Like this is an oil lamp that's been used by people for thousands of years. In its most simple form, you have a little jar of oil. This is just vegetable oil, and you have a wick, and the wick soaks up the oil, and you can light the wick, and the wick will burn. So you have an oil lamp. Like for example, in Greece, they're well known for growing olives, and they make olive oil, and you can use that olive oil in a lamp. Biomass can be used to power transportation. Corn is often used to make ethanol, and that ethanol is added to gasoline to power automobiles. So you make alcohol, and then you can mix alcohol in with gasoline, and that could power fuel. So like for example, isopropyl alcohol. Isopropyl alcohol is very flammable. Obviously you don't want to try this at home, but you can light it and it will burn. You may have seen a car that has a symbol that says this, flex fuel. 185 E85. Most gasoline, like around here, you go to Speedway, it has 10% or 15% ethanol or alcohol in the gasoline. This could be up to 85% alcohol. Here's a clip of some students burning alcohol.
Are you guys good?
Yes.
Okay, good.
Biomass can be used to power transportation. Vegetable oil can be used to power diesel automobiles. It's going to be called biodiesel. Here, this is a story that I saw on the internet of this guy who would drive around and pick up used cooking oil, like from Chinese restaurants, places like that. Even behind our school, we have this thing. It looks like a little dumpster, but that's used to put cooking oil in. So you'd take used dirty cooking oil and filter it and clean it and use it to power his truck. Here you see some girls doing the same thing. They're collecting vegetable oil and they're going to use it to power their diesel car. I do have a video on my channel. You can look it up. Does food burn? You can check that one out, and that's going to show various different food products that are flammable, like for example Fritos. Biodiesel. Why is biodiesel? What are some negatives? What could be bad about biodiesel? The most obvious is that when you burn things, it creates air pollution. In fact, biomass can have a real large amount of air pollution. One of the biggest negatives of biomass is just how much space it requires. It requires a lot of space to grow the crops to begin with, and then even more so and more expensive is having the space to store it. Well, guys, that's all we have for today. Our next lesson is going to be on non-renewable energy resources. Hope to catch you then. See ya.